Hello, folks. We will finish this nomenclature chapter with this video. We're going to talk about hydrates and acids. So, this is just one more extension onto the nomenclature bit. Hydrates we will not spend a lot of time on, but acids we'll spend a little bit of time on because these will be things we will use in regular, everyday chemistry. So we need to know how to name them. Okay, so hydrates. Hydrates are essentially an ionic solid that binds with additional atoms of water. First we need to understand, remember, hydro or hydrous means to be mixed with hydra, which is our water. A or an is the prefix used to mean with, without or missing, like an asynchronous orbit would be like it's not synchronized. And this anhydrous would be something without with the absence of water. But occasionally solids will bind with water without being dissolved. They will incorporate water into their crystal structures. In fact, this is what will give many crystals their beautiful color. The fact that they bound with additional atoms of water will change a white or colorless solid into, say, something that's blue or green or red. Having bound with water, it changes the color. Now, these solids are called hydrates. Now, while the water is not bound in a traditional ionic fashion, they're not held in place by ionic attraction. There's a weaker intermolecular force holding it in place, but it's still equally there. The idea here is that when it's represented in a chemical formula, the compound, usually usually a ionic compound, I think almost always an ionic compound, will be followed by a dot, a center dot, not a period, but a dot that appears in the center of the element, and it will have a coefficient followed by the water. That coefficient represents how many waters are present in this structure. For every one formula unit, how many waters are bound to that formula unit. So, example, copper sulfate, and that's 5 waters. So, for every 1 copper sulfate, there are 5 waters bound to it. And so if there's 100 copper sulfates, there's 500 waters. But we would call this a pentahydrate. The penta tells us how many waters. So it's the same prefix as we used in the binary molecular compounds. You could have a monohydrate, a dihydrate, a heptahydrate, a decahydrate. It all depends on the structure. But please note, this compound is still a solid, and it's not simply a solution. If you keep binding more and more waters to it, it can eventually dissolve. In fact, certain compounds will naturally dissolve in moist air. They're called deliquescent. And like your basic damp rid is an example of these guys. They will absorb moisture from the air and eventually turn into a gloopy mess because they're so good at attracting the water. But in the process, it makes moist air to be dry air. But if it's absent of the water, as I said, it's anhydrous. So we can have, sometimes we just call it copper sulfate, copper 2 sulfate, but sometimes we'll call it anhydrous copper 2 sulfate to specify the difference. However, we will typically not use that very often. But there are certain bottles, chemicals, that buying them as a hydrate is cheaper, even though you're getting extra weight of water. Now, acids and bases. We've already seen our bases, but the idea of these are two classes of compounds that will come up later very often. That an acid is a compound that has typically a hydrogen molecule that can donate. It has a hydrogen that is acting as if it was an ionic cation rather than a covalently bound nonmetal. Even though hydrogen is a nonmetal, it's acting like a cation in an ionic compound. That when we mix these acids, they will donate and lose that hydrogen atom. And this hydrogen atom, because of the ionizable hydrogen atom, will form hydronium in water. So this is water, H2O becomes H3O plus. This is the other this is the other polyatomic cation we will see with some degree of regularity. So the basic reaction, if I take HCl gas, hydrogen chloride gas, and I dissolve this in water, it becomes hydrogen chloride aqueous, but it becomes an acid because it is capable of losing this, and it becomes no longer is called hydrogen chloride, but it's called hydrochloric acid. Now, many anions will become acids when you add a hydrogen to it, including many of our polyatomic anions. But there are a few notable exceptions that will not be acids. CH4 is methane, BH3 is borane, PH3 is phosphine, and NH3 is ammonia. These guys do not contain ionizable hydrogen atoms, and so they get named completely different, and we will not see them on any sort of tests, at least not on this. Now, quick note, a base, which is the perfect counter to an acid. A base is a compound that will dissolve in water to produce hydroxide. This is our simplest definition. Now, because it delivers an hydroxide, an OH minus perfectly pairs up with an H plus. An H plus and OH minus forms H2O, water. So an acid and a base will naturally always react to form water and the corresponding ionic salt. So sodium hydroxide is a base. We don't name our bases differently. We just name them like normal. But sodium hydroxide, and if you mix sodium hydroxide with hydrochloric acid, you get water and sodium chloride salt solution. But we need to know, how do we name our acids? How do we go about naming our acids? Well, there's only really two major classes we need to worry about. If the compound had an IDE ending, which is most of your monoatomic anions, we change it thusly. We add a hydro to the prefix, and we add an IC acid. Hydrogen chloride becomes hydrochloric acid. Hydrogen bromide will become hydrobromic acid. Hydrogen sulfide becomes hydrosulfuric acid. There's hydrogen cyanide would become hydrocyanic acid. Any IDE ending gets a hydro, and the IDE changes back to a ic and then an acid. If it is a polyatomic that contains an 8 it changes one way. If it contains an ite, it changes another way. But we're going to change those in one simple way. So anything that contains an ATE ending will just change to an ic acid. Ic acid. So all the ATE is ic. Whether it's sulfate becomes sulfuric acid, or acetate becomes acetic acid. Oxalate becomes oxalic acid. Any ATE changes to IC. Any oxyaniide that contained an ITE changed to an US acid, OUS. OUS. So, and it doesn't matter what prefix they had, it just changes the suffix, which is the ending. So hypo stays hypo, so hypobromite becomes hypobromous acid. Just the only guys that get the hydro in front of it is ones that had the IDE ending. So, 8. I ate too much and now I feel icky. I feel icky because I ate too much. You'll just take a small bite and that means more for us. Small bite means more for us. But I ate the whole thing and now I feel icky. So we'll finish off real quick with some practice and then one last slide. Okay. Please note, if there's even a single metal in there, it is not an acid. These are not acids because it has to have only hydrogens. So this is still potassium. It's a phosphate. And there's 2 hydrogens. So it's dihydrogen phosphate. That's still sodium. That's a carbonate. And it's hydrogen carbonate. Now this is just H and F, and H and I. So we just have to call that. That would normally be a fluoride, but the ide becomes ic acid. Now because it's an IDE, we have to add the hydro. So this is hydrofluoric acid. This would be IDE, iodide. So iodic acid. But becomes, because of IDE, it's hydroiodic acid. This guy was an 8, sulfate. So this becomes sulfuric acid. Do we need to know that there's 2 hydrogens? No, because sulfate is always 2 minus. If it's an acid, there must be 2 plus. Every hydrogen is always plus 1, so we know there's always 2 hydrogens. This is an ite. PO3 is phosphite. So it becomes phosphorus acid. Phosphorus acid. Do we need to know there's 3 hydrogens? No, because this is always 3 minus. That means that must always be 3 hydrogens. we can use that to our advantage. So the last slide is just a quick overview of, hey, follow this chart. Yes, you don't have to use this chart. This chart is very hard to read. But basically, it's saying, okay, if you start here, is it covalent or ionic? If it's ionic, is it monoatomic cation? No. If it's polyatomic, you have to look up the name. It's ammonium. Constant charge? Yes. It's just the name of the element. No. We need the Roman numeral, so that deals with the cation. If it's covalent, is it an acid? No. First element, prefix, not for mono. Second element, prefix, IDE. If it's an acid, is it a binary acid? Yes, hydroblankic acid. No, we have to do with the oxyacids. Hypo us, ic, parodic. If it's the ionic monoatomic anion, no. Oh, yes, it's just IDE. No, but is it not an oxyanion? We have to look it up. Is an oxyanion? Yes. Hypoite, ate, parate. It's just a quick review of what we've been going over. But that is this whole chapter. I know it's very intense, very long. Bear with me. I know you can do it. I have you have my trust.